Good afternoon. Welcome to today's lesson on section 6.6. It's a pretty easy lesson. We'll just be solving a bunch of equations. That's usually the case at the end of each unit. Whatever main topic we have, we want to solve equations that deals with that topic. So these examples are from the book, and I put the example number and page number so you can reference that if you'd like to. Very important though, at the end of each problem we will have to check our answers because sometimes the answer may not work. And again, like any equation, you always want to isolate x. So in this case here, we have the cube root of 2x plus 7 equals 3. So in this case, I'm going to cube both sides. The reason why is because what's the inverse of cube rooting? Cubing. And you always want to do the inverse operation to whatever's connected to x. So 2x plus 7 equals 27. 2x equals 20. X in this case equals 10. And if we check our work, it should be pretty easy to do. 2 times 10 plus 7 equals 3, cube root of 27 equals 3, 3 equals 3. Here's another one. Now, if you think about it, it's kind of like a radical equation. Because remember, x at 3 halves is like saying the square root of x cubed. So we can actually rewrite this as 4 times the square root of x cubed equals 108. Divide by 4. Square both sides, which actually does get to be pretty nasty here. So my human calculator skills are a little rusty, so let me get my trusty calculator. 27 squared is 729. Then we have to cube root both sides, because that's the whole point. If you want to get x by itself as being cubed, you have to cube root to get rid of the cube symbol. And the cube root of that would be 9. So x equals 9. Now another way you could have done this is leave it in a rational exponent form. And now remember, only the x is being risen to the 3 halves power. So you got to divide by 4 first. We don't have this. If we had this, then we didn't have to divide by 4 first. Then in that case, we would get rid of the exponent. And the way you get rid of the exponent is you raise both sides to the 2/3 power. So those cancel. So that'll be 3 squared, which is 9. And here's why I knew that, is because if you look over here, 27 to the 2/3, it's like saying 27 to the 1/3, then squared, which I know is 3, then 3 squared is 9. So a couple ways you could do that one. So for number 3, I'll solve it like the way I did it number 2 for the second solution. Let's first add 1, and then raise both sides to the 4/3 power. So those go away, because remember, you multiply the exponent and you're multiplying a fraction by its reciprocal, so it goes away. 8 to the 4/3, one being 16 if you work it out, because 8 to the 1/3, then raised to the 4th power, so x equals 14. I did forget to check for number 2. I'll come back to that, but if I did 14 plus 2 raised to the 3/4 minus 1 equals 7, and it does work out. And if I were to check over here, 4 times 9 to the 3 halves equals 108. That'll be 4 times 27 equals 108. So that works as well. Okay, a couple more, and we're done. Now here we actually have a square root. So we're going to square both sides. Now be careful. You got to FOIL the left side. So please, 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 please do not make this mistake. Do not say that x plus 1 squared is x squared plus 1. That is a huge, huge error. You must FOIL x plus 1 with itself. And of course the right side is 7x plus 15 because you have the square root, and the square gets rid of the square root. Move things around. Factor. And we get 2 answers. But I'm usually suspicious when I see 2 answers. So if I check, 7 plus 1 equals root 7 times 7 plus 15. 8 equals 49 plus root 49 plus 15, root 64. So that works. If I check the other one, now right off the bat I know it doesn't work, and here's the reason why. Negative 2 plus 1 is negative 1. A square root can never equal negative 1. See here this becomes root 1, and root 1 is 1, so that doesn't work. Okay, last one, number 5. Now this one's a little tricky, because usually what you want to do is you want to isolate the radical as much as possible prior to squaring both sides. So notice how for number 4, the radical is very isolated, so it made it easy to square both sides. The problem is we get 2 radicals, so the best way I could separate it is just the way it is right now. So let's go ahead and start squaring both sides, but you're going to have to be careful. Because you're going to have to FOIL. I would probably recommend pausing the video, FOIL the left side, see if you get the same thing as I do, and then replay the video, or then hit play. So here's what we get. 1 plus 2 root x plus 2 plus x plus 2, because root x plus 2 times root x plus 2 is x plus 2. Then continue your isolation process. These will all cancel. Divide by 2. Now square both sides. Remember, negative x times negative x is x squared. Move things around. And so we get 2 answers, 2 or negative 1. If we check, like when x equals 2, that doesn't work. So it's kind of weird because in this case the positive value didn't work. So you can't always assume the negative value is going to be wrong. And there's a chance that sometimes neither will work. If I try negative 1, so that works. So the answer is negative 1. Okay, so as I promised, try to keep this video short. That was about a 10-minute video. I will assign some problems on our agenda. Go and check those out. And have a good rest of the weekend. See you on Monday.